Have you ever tried assembling IKEA furniture, only to find that the holes just don't line up, no matter how hard you try? It's incredibly frustrating, and it makes you wonder if perfect alignment is even possible in the real world. Now, take that same problem and imagine it happening during the assembly of a jet engine, where the stakes are much higher and the parts are far more complex. In engineering, even the tiniest misalignment, sometimes just a fraction of a millimeter, can lead to catastrophic failure or costly rework. For decades, engineers relied on a simple plus or minus system to locate holes, which created a square-shaped tolerance zone on their blueprints. But here's the catch. A round peg doesn't fit a square rule, and this mismatch causes real problems in manufacturing. The old system could easily reject perfectly good parts, while sometimes allowing bad ones to slip through, leading to confusion and waste. This led to wasted time, wasted money, and endless headaches on the assembly line as workers struggled to make things fit. The real solution? A smarter, more accurate system that actually reflects how parts fit together in the real world, reducing errors and improving quality. Enter geometric dimensioning and tolerancing, better known as GD&T. A revolutionary approach that changed the way engineers communicate tolerances. And at the heart of GD&T is one powerful symbol that makes all the difference: the true position symbol. The fix, true position, the superstar of GD&T and the unsung hero behind so many reliable assemblies. It defines the exact, ideal location for features like holes, using basic dimensions as perfect targets, ensuring every part lines up just as the designer intended. Instead of a square, true position creates a cylindrical tolerance zone, matching how bolts and holes actually work in the real world, not just on paper. The crosshair symbol in a feature control frame tells manufacturers exactly what's needed, removing ambiguity and confusion from the process. With true position, as long as the hole's center falls within the cylinder, the bolt fits. No more guesswork, no more trial and error, just precision. It's a simple, effective system that bridges perfect design and real-world manufacturing, making quality control straightforward and reliable. No more hammering parts together or forcing misaligned components to fit. True position makes assemblies work every time, ensuring products are built right from the very first part to the last. Let's break down the cylindrical tolerance zone. This concept is crucial in precision engineering, ensuring that parts fit together seamlessly. The old square method limited you, but true position's cylinder gives more room, 57% more area in fact. This extra space allows for greater flexibility and accuracy in manufacturing processes. The feature control frame spells out the rules, the crosshair symbol, the diameter of the tolerance zone, and the datums. It's like a blueprint for precision, guiding every step. Datums are your part's anchors, flat surfaces or edges that set the reference for all measurements. They are the foundation upon which accuracy is built. They lock the part in space, so everyone measures the same way. This uniformity is essential for maintaining quality across different production batches. Without datums, you're lost, like a treasure map with no starting point. It's a chaotic scenario that can lead to costly errors. The inspector sets the part on the datums, then checks if the hole's center is inside the cylinder. This step is crucial for ensuring that each component meets the design specifications. This process removes ambiguity and ensures consistency. It's the backbone of reliable manufacturing, reducing waste and improving efficiency. That's how GD&T brings precision to manufacturing. It's a language of accuracy that transforms ideas into reality with exactness and reliability. Now, the GD&T superpower, maximum material condition, or MMC. MMC means the smallest hole or largest pin, when there's the most material. If a hole is made bigger than its minimum, you get bonus tolerance for its position. The feature control frame shows this with a circled M. The bigger the hole, within limits, the more wiggle room you get for its location. This flexibility reduces scrap and saves money without sacrificing fit. MMC rewards precision and efficiency. It's a win-win for manufacturers and engineers. Smart design, smarter production. True position is everywhere, from cars to smartphones to satellites. To check it, engineers use coordinate measuring machines, CMMs, or functional gauges. A CMM touches datum surfaces, measures the hole, and checks if it's within the tolerance cylinder. Gauges offer a quick, physical test. If the part fits, it passes. The key is always referencing the datums and the cylindrical zone. Common mistakes? Confusing. True position with old plus or minus tolerances, or ignoring datums. Mastering true position means your designs work in the real world. It's the secret behind every complex machine that just works.